Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concepts in our today's session. So, let us start our session. As you get up early in the morning, you are surrounded by numbers. Not only that children, yes, the entire world moves around the numbers. Children, can you imagine the world without numbers? You cannot imagine it, isn't it children? Let us see few examples. A calendar, a school or an office and your clock. Now, this calendar is not going to be existing because it is made of numbers, and even people cannot reach the office or students to the school on time because you don't know how to use the time or the watch. And here clock, there won't be any clock also. Now, these all are just a simple and some of the applications of numbers in our daily life. Okay, children. But do you know what are divisibility rules, children? Yes. The divisibility rules actually help us in finding whether the given number is divisible by another number or not without doing division. So, actually we are not going to perform any division, children. Without actual division, we are going to tell whether that number is divisible by any given number or not. Okay, children. So, today in our lesson, that is playing with numbers part 1, we are going to discuss more about these division rules. So, by the end of this session, you will learn place value of a digit, expanded form of a number, factors and multiples of numbers, and finally divisibility of numbers. So, children, let us first see about place value of a digit. So, let us consider an example, children. We are going to find the expanded form of 862. Children, you have learnt already this in your previous classes. So, 862. If you notice, 8 is in hundreds place. So, we write 8 into 100 plus 6 is in tens place. So, we write 6 into 10 plus 2 is in ones or units place. So, we multiply 2 with 1. This is called as the expanded form of a given number, and here the place value of 8 is 800, whereas the place value of 6 is 60. Now, children, let us learn about expanded form of numbers now. So, let us consider an example. So, we are taking a tabular form, we are going to write the numbers in standard form and expanded form. If you notice, 45 can be written as 40 plus 5. Now, this 40 further can be written as 4 into 10 plus 5. So, which gives us again 45 only. So, since here there is no power over here, I can write it as 10 raised to the power of 1 into 4 plus 5 can be written as 1 into 5. But children, we have already learnt in our previous class, any number raised to the power of 0 is 1. So, 10 to the power of 0 is also 1. So, I can write it as 10 power 0 because it is 1 into 5, you get back 5. Now, let us take another example, children, that is 69. Now, 69 can be written as 60 plus 9, again 60 is 10 into 6, that becomes 60 plus 9. Again 10, we write it as 10 raised to the power of 1 into 6 plus, here only 9 is there, which is nothing but 1 into 9. So, 1 can be written as again 10 raised to the power of 0 into 9. So, this is how we generally write the expanded form, children. Suppose if A and B are in tens and units place, then the number 10A plus B can be written as, how do we write, children? So, 10 to the power of 1 into A plus 10 to the power of 0 into B, where A is in tens place and B is in ones place or units place, children. So, now children, you know how to write the given number in expanded form. Now, let us take another example, say 157. Now, this can be written as 100 plus 50 plus 7. 100 can be written as, I will write it as 100 into 1 plus 10 into 5 plus 1 into 7. Now, further this one, I can write this as 10 square into 1 plus 10, here there is no power. So, I can write power as 1. So, 10 raised to the power of 1 into 5, and already we have seen 1 can be written as 10 to the power of 0 into 7. So, this is how we write the expanded form of 157. Now, let us take another example, 764. So, this is the standard form 764. I am writing it into 700 plus 60 plus 4. So, in the same way as done in the previous case, we write it as 100 into 7 because we have 700 plus 60 is written as 10 into 6 and 4 we are writing it as 1 into 4. Again 10 is written as 10 square. So, into 7 plus 10 to the power of 1 into 6 plus again 1 is written as 10 power 0 into 4. So, 100a plus 10b plus c can be written as 10 square into a plus 10 to the power of 1 into b plus 10 to the power of 0 into c. Here a is in hundreds place, b is in tens place and c is in units place or the ones place. So, children, let us move on to our next concept, that is factors and multiples of numbers. So, to understand this, let us consider an example of 24. So, here we are going to find the factors of 24. So, I can write 24 as 1 into 24 and it can also be written as 2 into 12. Now, can you guess what is the next one, children? You are right, it is written as 3 into 8. Further, I can write 24 as 4 into 6. So, this is how we can write 24 in different ways. Now, what will be the factors of 24 here? So, if you notice here all these numbers which you have written on the right side, that is 1 into 24, 2 into 12, 3 into 8 and 4 into 6. This 1, 2, 3, 4, 6, 8, 12, 24. These are all are called factors of 24. So, I can write the factors as 1, 2, 3, 4, 6, 8, 12 and 24. Now, take a look at another example, children, that is factors of 30. Again we write 30 as shown, 30 is equal to 1 into 30 or 2 into 15 or 3 into 10 or even we can write it as 5 into 6. Again, what will be the factors here, children? Yes, you are absolutely right, that is 1, 2, 3, 5, 6, 10, 15 and 30. Now, let us summarize these concepts what we have learned, children, from these examples. If you notice, in the first one, factors of 24, the highest factor is 24. And what about the next one, children? Yes, in factors of 30, the highest factor is 30. That means, I can write the greatest factors of 24 and 30 are 24 and 30 itself, isn't it, children? Now, let us move on to the next one, that is every factor is less than or equal to the given number. Now, let us see all these factors, children. What are the factors of 24, 1, 2, 3, so on up to 24. If you notice all these numbers, they are less than or equal to 24. See, all these up to 12, they are less than and 24 is equal to 24. Not only that one, children, even for 30 also, if you notice, all these factors up to 15 are less than 30, whereas the last factor is 30, which is equal to the number 30, isn't it, children? Now, let us see another one. The greatest factor of a non-zero number is the number itself. Now, if you take this is a non-zero number, what is the greatest factor of 24? 24 itself. What is the greatest factor of 30? 30 itself. So, these are the concepts that we learned from these examples, children. Not only that, if you notice, in the factors of 24, we have 1 and in factors of 30, we have 1. So, if you consider factors of any other number also, 1 is a factor of every number. Not only that, every number is a factor of itself, that is 24 is a factor of 24, 30 is a factor of 30. If you consider say some 100, factor of 100 will be 100 itself. Okay, children. So, if a natural number other than 1 has no factors except 1 and itself, then it is called a prime number. So, what are prime numbers, children? Yes, prime numbers are 2, 3, 5, 7, 11, 13 and so on. Why do we call them as prime numbers? Because they have only two factors, that is 1 and the number itself. So, if you take a look at 13, what are the factors of 13? 1 and 13. So, 1 will be the common factor and also the number itself is a factor. Such type of numbers which have only two factors are called prime numbers. Now, let us see the number of factors of a given number. If a number can be written as the product of primes, just now we have seen what are primes, right? Suppose a number is there n, I am writing this number n as the product of prime numbers, that is 2 to the power of a into 3 to the power of b into 5 to the power of c and so on. It can extend to any number of primes. Then the number of factors of n are given by a plus 1 into b plus 1 into c plus 1 and so on. That means, suppose if I have here 7 to the power of d, I get into d plus 1 also, children. I hope you understood this. So, let us take one example to understand this concept clearly, children. So, find the number of factors of 60. So, consider 60. Now, let us factorize this. We are going to do prime factorization. So, the first prime is 2, it goes 30 times. So, I will write 60 as 2 into 30. Then again 30 is divisible by 2. The next again the same prime factor, right, 2. It goes 15 times. So, I write it as again 2 into 2 into 15. Why? This 2 remains same, whereas 30 is written as 2 into 25. Now, if you notice, this 15 is not divisible by 2. So, you need to go for the next prime number. So, what is the next prime number, children? Yes, it is 3. Now, 3 goes in 15 how many times? Yes, 5 times. Again, I will write this as 2 into 2 as it is. Now, 15 is written as 3 into 5. Now, we have 5 left here. Now, if it is not divisible by neither 2 or 3, so go for the next prime number, that is 5. So, what do you get, children? Yes, it goes only one time. So, if you notice here, there are 2 2's, product of 2 2's. I can write it as 2 square. Into how many 3's are there, children? Only 1 3. So, I write it as into 3 power 1. Now, what about 5? Yes, we have only 1. So, this also written as 5 to the power of 1. Now, we have converted this 60 into the product of prime factors. Now, let us see how to find the number of factors, children. So, if we compare this 2 to the power of 2 into 3 power 1 into 5 power 1 with 2 power a into 3 power b into 3 power c, what do you get, children? Yes, I get a is equal to 2. So, in place of 2 power a, so I have 2 power 2, that means a is equal to 2. Then we have 3 power b, so in place of b I have 1, so b is equal to 1. Now, what about c, children? Yes, that is also equal to 1. So, the number of prime factors is given by the formula a plus 1 into b plus 1 into c plus 1, right. So, here a is 2, so we are substituting 2 plus 1 into 1 plus 1 into again 1 plus 1. So, what do we get, children, now? We get 3 into 2 into 2. On multiplying these 3, you get 12. That means, we can say that the number of factors of 60 are 12. I hope you understood how to find the number of factors, children. So, let us see what do you mean by multiples of numbers. The product of a number with any integer is called the multiple of that number. Let us take an example. I will find the multiples of 8 here. So, when I multiply 8 with 1, I get back 8, whereas when I multiply with 2, I get 16. Similarly, 8 into 3 is 24, 8 4 is 32, 8 5 is 40 and 8 6 is 48. Now, all these are called multiples of 8, that is 8, 16, 24, 32, 40 and so on. You can write infinite number of multiples of 8. Till now, we have learnt about place value of a digit, factors and multiples of numbers. In that, we have even solved an example to find the number of factors of a given number. Now, we are going to learn about the divisibility rules. Let us start with the first one, that is divisibility by 10. If the unit digit of a number is 0, then the number is divisible by 10. So, this is the first divisibility rule. So, for example, if we consider 10, 20, 30, 40, 50, so on, all these numbers, if you notice, what is there in its units place or ones place? 0, right. So, everywhere we have 0 in the ones place or the units place. Then these numbers are divisible by 10. Now, let us take two more examples, that is 3510 and 657. If you notice the first one, that is 3510, the ones or units place is 0. That means, this number is divisible by 10. Now, take a look at the second number, 657. Here the ones digit is 7. So, here according to the definition, if it has only 0, then only it is divisible. So, the 657 is not divisible by 10. Now, let us move on to our next divisibility, that is divisibility by 5. If the unit digit of a number is 0 or 5, then the number is divisible by 5. Let us take examples like 5, 10, 15, 20, 25, so on. All these numbers are divisible by 5. Why these are divisible by 5, children? If you notice the ones digit, if you notice here in 25 it is 5, in 20 it is 0, in 15 it is 5. So, that means always unit digit ends with either 0 or 5. So, that is why these numbers are divisible by 5. So, let us take two more examples here, 2150. Now, in this case the unit digit is 0, hence it is divisible by 5. Whereas, if we consider the second number, that is 9527, here the unit digit is 7. So, it is neither 0 nor 5. So, I can say that this number is not divisible by 5. So, let us understand the logic behind these children. So, let us consider a 3-digit number as 100A plus 10B plus C. Then here A is in hundredths place, or A is hundredths digit, and B is the tenth digit, and C is ones digit. Now, this can be written as, that is 100A plus 10B plus C can be written as 5 into 20A plus 2B plus C. Why? Because these two numbers, if you consider these two terms, I have taken 5 as common factor. So, that is why 5 into 20A plus 2B plus C. If you notice this number, that is 5 into 20A plus 2B, this number or these terms, I can say it is a multiple of 5, because it is 5 into something. So, 5 into any number is nothing but a multiple of 5, means it is divisible by 5. Now, what is the number which is left? Yes, plus C. So, this C value we have to find. So, the value of C should be either 0 or 5. So, this is the logic behind this statement, children. Now, let us move on to our next divisibility, that is divisibility by 2. So, if the unit digit of a number is either 0 or 2 or 4 or 6 or 8, then the number is divisible by 2. So, you can see the examples like 2, 4, 6, 8, 10, so on. I can say these are all even numbers also, isn't it, children? So, all these numbers are divisible by 2. So, let us understand again the logic once again. So, we have taken the 3-digit number 100A plus 10B plus C. Now, already we have seen A is hundredths digit, B is tens, and C is ones digit. Now, what I am going to do is, in these two terms, I am going to take 2 as common factor. So, if I take 2 as common factor, what is left here? 50A, and from 10 I have taken 2 common, so I get 5B. So, I get 2 into 50A plus 5B plus C. Now, again this 2 into 50A plus 5B, this is a multiple of 2, which means that is divisible by 2. Now, what is left now? Only C. Then the C value should be either 0 or 2 or 4 or 6 or 8. So, this is the logic behind this divisibility rule, children. Let us move on to our next divisibility rule, that is divisibility by 3. If the sum of the digits of the number is divisible by 3, if you consider examples 3, 6, 9, 12, 15, so on, all these numbers are divisible by 3. So, let us see the logic behind this again. Consider the same 3-digit number once again. Now, in this 3-digit number, I am going to split this 100A as 99A plus A. So, this gives back again 100A, right. Now, 10B I am writing it as 9B plus B. So, again I will rearrange them. So, I get 99A plus 9B, I am taking it as separate, and then we are left with A plus B plus C. Now, in 99A plus 9B, I am taking 3 common. So, even though 9 is common, but I want only 3 to be taken out. So, I am taking 3 common. So, what is left? 33A plus, from 9 3 is removed. So, taken common. So, we are left with 3B plus, here we have A plus B plus C. Now, if you notice, this 3 into 33A plus 3B is a multiple of 3, means it is divisible by 3. Now, what is left now? Yes, A plus B plus C, that is the sum of digits. Now, if A plus B plus C is a multiple of 3, or if this A plus B plus C is divisible by 3, then I can say that the given number is divisible by 3. So, hence I can conclude that a number is divisible by 3 only if the sum of the digits is a multiple or divisible by, okay, children. Let us move on to our next divisibility rule, that is divisibility by 9. So, here also it is almost similar to our divisibility by 3. So, a number is divisible by 9 if the sum of the digits of the number is divisible by 9. So, examples you can take 9, 18, 27, so on. All these are examples of numbers which are divisible by 9. So, let us understand the logic again. We are going to consider the same 3-digit number 100A plus 10B plus C, where A, B, C are 100, tens and ones digit. Now, again I will write it as 99A plus 9B plus B plus C. Now, again rearranging them, I get 99a plus 9b plus, again sum of terms a plus b plus c. Now, in this 99a plus 9b, I am taking 9 common. So, if I take 9 common here, I am left with 11a plus b, and a plus b as it is, no change. Now, from this what do we conclude, children? Yes, here this is simply 9 into 11a plus b is a multiple of 9. If this a plus b plus c is also multiple of 9, that is sum of digits is multiple of 9, or if a plus b plus c is divisible by 9, I can say that the given number is also divisible by 9. So, what do you conclude, children? Yes, the number is divisible by 9 if the sum of the digits is a multiple of 9 or divisible by 9. Let us move on to our next divisibility rule, which is divisibility by 6. If a number is divisible by both 2 and 3, then it is divisible by 6. Let us take some examples, children, like 6, 12, 18, 24, 30, so on. These are all examples of numbers which are divisible by 6. Let us understand them. So, I am taking an example here, 2514 and 8056, and I am going to check whether they are divisible by 6 or not. So, let us consider the first number, that is 2514. Now, this number is divisible by 2 as the ones digit is 4. We have already learned the divisibility by 2. Now, we will check whether this number is divisible by 3 or not. So, for that we will consider the sum of the digits, that is 2 plus 5 plus 1 plus 4. What do you get, children? Yes, and adding them you get 12. Now, is 12 a multiple of 3 or is it divisible by 3? Yes, it is divisible by 3 or it is a multiple of 3. That means, I can say 2514 is divisible by 3. Now, if you notice, this number, that is 2514, is divisible by 2 as well as by 3. Hence, I can say that 2514 is divisible by 6. Let us move on to our next example, that is 8056. Now, since in the ones place we have 6, this number is divisible by 2. Now, let us see the sum of digits, 8 plus 0 plus 5 plus 6. What do you get, children, now? Yes, you are going to get 19. Now, is 19 a multiple of 3 or is it divisible by 3? No. So, we can say that 8056 is not divisible by 3. So, what do you conclude from this, children? So, first this 8056 is divisible by 2, whereas it is not divisible by 3. Hence, I can say that 8056 is not divisible by 6. If it is divisible by both 2 as well as 3, then only it is divisible by 6. Got it, children? If it is divisible by any one of them, it is not divisible by 6. Now, let us move on to our next divisibility rule, that is divisibility by 4. So, let us consider a 4-digit number as shown. Now, I am going to take 4 common from these two terms, first two terms. So, if I take 4 common, I get 250a plus from 100 I have taken 4 common, I get 25b plus 10c plus d as it is, no change. Now, if you notice this number, that is 4 into 250a plus 25b, it is a multiple of 4 or it is divisible by 4. Now, what is left now? 10c plus d. Now, this should be also multiple of 4 or 10c plus d should be divisible by 4. Then I can say the given number is divisible by 4. So, what do you conclude, children, from this? In a given number, if the number formed by last 2 digits is divisible by 4 or last 2 digits are simply 0, then that number is divisible by 4. Now, let us move on to divisibility by 8. Again, we are going to consider a 4-digit number as shown, and in this case we are going to take 8 common in the first one, that is 1000a. So, in 1000a, if I take 8 common, I can write it as 8 into 125a plus 100b, 10c and d as it is, no change. Now, this particular number, that is 8 into 125a, is a multiple of 8 or is divisible by 8, whereas the left 3 terms, that is 100b plus 10c plus c, it should be a multiple of 8. Then only I can say this number is divisible by 8. So, I conclude that in a given number, if the number formed with its last 3 digits are divisible by 8 or last 3 digits are simply zeros, then that number is divisible by 8. Now, let us apply these concepts in solving few examples. Let us start with the first example. A number 34a is exactly divisible by 2 and leaves a remainder 1. when divided by 5. Find A. Let us start with the solution. So, we know that if the unit digit of a number is either 0 or 2 or 4 or 6 or 8, then it is divisible by 2. Hence, I can say that the given number is exactly divisible by 2. This is given to us. So, hence A can be either 0 or 2 or 4 or 6 or 8. And it is also given that 3, 4 A leaves remainder 1 when divided by 5. That means, we already know that a number is divisible by 5 if its unit digit is either 0 or 5. Hence, I can write A can be either 1 or 6 because 0 and 5 are rolled out. The remaining numbers, if I have 1 in A's place, when we divide by 5, I get 1, or even if it is 6 in place of A, then I get remainder 1. So, what do you notice in these two? Yes, 6 is the common digit, right? Therefore, the value of A is 6. Hence, the number is 346. Let us move on to our next problem, children. 27Q leaves remainder 3 when divided by 5 and leaves remainder 1 when divided by 2. What is the remainder when it is divided by 3? Let us start with the solution. And we have already seen a number is divisible by 5 if its unit digit is either 0 or 5. Hence, when the given number is divided by 5, it is leaving a remainder 3. So, what is the value of Q, children? Yes, either 3 or 8. And also it is given that when the given number is divided by 2, the remainder is 1. Hence, the value of Q is either 1, 3, 5, 7 or 9. Now, if you notice in these two, the common digit is or the common number is 3. Hence, I can say the value of Q is 3. Therefore, what is the number, children? Yes, it is 273. So, children, till now we have learnt about place value of a digit, factors and multiples of numbers, divisibility rules, and we have solved few examples also. So, before we conclude, let us quickly recap what we have learnt in this session. If the unit digit of a number is 10, then it is divisible by 10. A number is divisible by 5 if its unit digit is either 0 or 5. If the unit digit of a number is 0 or 2 or 4 or 6 or 8, then it is divisible by 2. A number is divisible by 3 if the sum of the digits of the number is divisible by 3. A number is divisible by 9 if the sum of the digits of the number is divisible by 9. If a number is divisible by both 2 and 3, then it is divisible by 6. A number is divisible by 4 if the number formed by its last 2 digits is divisible by 4. In a given number, if the number formed by its last 3 digits are divisible by 3 or zeros, then the number is divisible by 8. So, before we conclude, children, I would like to give you some assignment to work it at your home and submit to your teacher. So, children, with this we have come to the end of our session. I hope you have learnt all the concepts clearly and understood applying these concepts in solving few problems. So, with this we stop here itself and will meet in our next digital class. Until then, goodbye and take care.